Okay, so this is going to go over some of the problems from the homework and quiz of Module 4, just showing how to work through those. This first one is a bond pricing question. So um, it says, even though normally we do semi-annual, other places they may have annual. So we're looking at a non-US bond making annual coupon payments. Don't get too caught up in that. Just understand almost always the bonds you'll be exposed to will be semi-annual. But sometimes we do work with annual more so because it's easier to start with. So this is going to be an annual bond. They tell us the number of years to maturity. They tell us the coupon rate. They tell us the par value. So the coupon rate times the par value will be the annual payment. They tell us the yield to maturity, and they ask what is the current bond price. And the current bond price would be the present value of those intermediate payments and the present value of that par value at the end. And so on the calculator, you would just hit 9 and then the N on the time value of money row. 10.6, you don't have to put percent, just 10.6, and then hit IY. 86 for payment, 1,000 for future value, and make sure those are put in with the same direction of flow. So either both positive or both negative. The present value you get is going to be the opposite sign. So if you put those in as positive, you're going to get a negative price. Just understand all it's doing is telling you whether you're paying out or you are receiving money. That's what the sign is for, is the direction of the cash flow. Um, but once you put in the four values that are given, hit the compute button in the upper left-hand corner and present value, and it'll tell you what the current bond price will be. This one looks a bit more complicated, but it's the same type of thing. But what we're going to do is calculate what the yields are once we get what those prices are. So same type of setup. They give us an interest rate. They give us the number of periods. They tell us what the par value is, right? It's 1,000. And so the difference for these bonds are the payments. Is it above or below that yield to maturity? So in one case, bond P, right? That's a premium bond. So it's $89 a year. And then the discount bond D, is $49 a year. So if your coupon payment is higher than the yield to maturity, it's going to be a premium bond. It's going to sell above par value. If it's less than that yield to maturity, then it's a discount bond and it's going to sell below par value. And so if you see on the left, we're going to do the premium bond first, right? And so you just put in the four pieces of information you have and solve for the present value, the price. And you can do that at time 0 and then at time 1, right? And then you'll see how those values differ, right? Because there's less time at P1 than there is at P0. Um, then to calculate the current yield, you'll take whatever your current payment is, and then you divide it by the current price, right? And then the capital gains yield, the way I always learned it is new minus old divided by old, right? So it's the newest price minus the old price divided by the old price. So in this case, it would be the P1, right? That's the newest one minus P0, and then you divide that by P0. Excuse me. And if you notice, the capital gains is negative. That makes sense for a premium bond because as premium bonds approach maturity, that premium starts to go away, right? So the price is going lower and lower as it approaches 1,000. When we do the same calculation over on the discount, you'll see that the capital gains is positive. That means that the price is appreciating through time. But again, we do the same type of calculation with that discount bond. We would get what the current yield is, and then we will get what the capital gains yield is. Okay. And if you um, add those two together, like the current yield plus the capital gains yield, you should get that 6.9 yield to maturity, because yield to maturity is the total yield or capital gains yield plus current yield, right? So even though they differ, and one has a higher current yield, the other one has a higher capital gains yield, they actually have the same total yield. So there's that. To calculate a coupon, it's the same type of calculation we did, only instead of computing the present value, now we're computing the payment. So they give us the information. They tell us that this is going to be an annual, coupon, and they tell us that the par value, they tell us what the current price is. And if you notice, when putting the data in, it shows future value as positive, and we would have to make the present value negative, right? So if we make that negative and future value positive, when it calculates payment, it will actually also be positive, and that indicates just as we receive $1,000 at the end of the coupon, we're going to receive $86.79 every year. So, but once you calculate what that payment is, you would just divide it by par value, and that will give you what the coupon rate is. They ask for it as a percentage, so you just need to move the decimal place over. Here's another one calculating a coupon rate. Again, this one looks a little more complicated, but it just shows you a bit more data, and a lot of that you don't need. So these are the bond quotes that we have. We're assuming that it's currently January 15th of 2022. The par value of these bonds are 2,000. They just did that. I can't tell you why. And then they are semi-annual payments. So what we're going to do when we put this in the calculator, I find it easiest not to try to change the periods per year, which you can do. But to me, it's easier just to leave that periods per year as one, as an annual thing. And you just have to manipulate your number of periods and your interest rate. So all you do is simply double the number of periods, because you're saying it's 16 years, and that's the same as 32 half years. And then it's 7% per year, which would be 3.5% every 6 months, right? So we can make that slight change, put in the price that it's currently selling for, and then put in the future value, right? And then based on that, we can just calculate what is our payment going to be. Now, we are doing the Williams Company bond in this problem, WICO, WICO. If you notice, it says last price 94.815, and you're like, what does that mean? That's the percentage of par. So you would actually say 2,000 times the 94.815%, and that gives you what that present value is. So that's how it told us, but it told us as a percent of par. Now, normally, as you know from doing these problems, bond par is almost always $1,000. And so what that ends up meaning is you just shift the decimal place over one in a normal problem, and it would be like $948.15. But this is a par of 2,000. There are bonds that have higher par. It's just corporate bonds in the U.S. are almost always $1,000. You will see like municipal bonds; those are normally $5,000, but those tend to be high net worth individuals. And for bookkeeping purposes, it's just easier to make it a higher denomination. Speaking of which, if you look at U.S. Treasuries, so like when the U.S. government sells their bonds, T-bills, T-notes, and T-bonds, those treasuries are $100,000 face value. So, and again, it's a bookkeeping thing because they're selling billions of dollars of debt every auction. So when that happens, that's why we quote this in this percentage. That way we can use the same system. And actually, honestly, it made a lot more sense when computers had a lot more restrictions and like the number of characters and things like that. These days, it doesn't seem like such a big deal, but it used to be. So, now as far as This next problem, this is talking about getting board seats. And this sounds kind of weird, but this does happen. Disney recently went through this twice with the same investor. His name was, it was Nelson Muntz. You might want to look that up. Nelson Muntz, Disney. And he was trying to get control of enough shares of stock to vote himself and a few others onto the board at Disney because he felt that they were not running the properties correctly, right? So Disney spent a lot of money to acquire Marvel and Star Wars and a lot of these large properties. And he felt that lately they've been losing a lot of money, and so they need someone else in charge. And in charge doesn't mean changing the CEO. Bob Iger would still be there, but the board oversees the CEO on behalf of the shareholder, as you guys know. So, as a very concerned and very wealthy shareholder, he was going to get on the seat, get on the board as a seat. Um, so that's what we're looking at here, and we have two different cases. One is straight voting, and then one is cumulative voting. So straight voting is basically you just get to vote, yay or nay. It's kind of like voting for president, and who wins? Whoever gets 50% plus one electoral college vote, right? In a local election like governor or whatever, it's whoever gets 50% plus one vote, right? So with that type of voting, you need to have half the company. And so for the cost of straight voting, we look at the number of shares outstanding, divide that by two, and know, okay, we need to buy that many plus one share because you got to have a little over 50%. And so we can take our current share price, $46, multiply by the number of shares we need, and that gives us the cost for straight voting. Okay, so for cumulative voting, that's where they say, okay, we have 3 seats up for vote. So here's 3 votes, and you get to vote for 3 people. But you can actually vote for the same person with all 3 of your votes. I know it sounds really weird, because we don't let you take your vote for senator and say, well, I'm just going to vote an extra time for governor instead, right? We don't let you do that. But some companies are set up so that, people that are really dedicated to getting a particular person on can do that by sacrificing other potential candidates, right? And so when we're looking at this one, what we're saying is this one has 4 seats. Yeah, so there's 4 seats. And so basically you just need to have 1/5 of the company, right? Because the way that the math works out, right? With 20%, you could guarantee one of those 4. Um, and so again, they need fewer shares, right? Because of this cumulative voting. But then you would be calculated the same way. So, like I said, this is a real world situation. I mean, when Elon Musk bought Twitter, when he did it initially, it was just one of these things to try to get some board seats, and then it kind of spiraled into something much larger. But yeah, you don't actually have to do a total buyout to get board seats, oftentimes because of the cumulative voting. Okay, here's another one looking at that calculator to work on the problem, and this is calculating yield to maturity. So just to kind of go over that calculator in a number of periods. So if they're ever asking you how many years would it take, that's what you're looking for. IY is the interest rate per yield, and normally when we're looking at this for a bond, that's going to be used to calculate the yield to maturity. If we're doing this with stock, that normally that's going to be required rate of return. The return you have to satisfy your shareholder. The PV and FV, that's just present value and future value. And then PMT is always going to be that payment. So as long as you remember that the plus or minus tells you the direction of cash flow, those parts are normally not as hang you up as much as the number of periods and the interest rate. And that's because we often have to either multiply by 2 or divide by 2. So that's what we're doing in this case. So we're going to calculate yield to maturity. And the problem is very straightforward, but the wrinkle is there is this semi-annual nature. So we have to double the number of periods. We'll put in the price the same as before, make it negative because we're going to pay that to buy, and then we're going to receive the payment and the future value. Now the payment is 8.8%, right? And it's $1,000, so that would be $88, but they're semi-annual payments, so you only get 44 each 6 months. So they just divide that by 2. But once we do that and we compute IY, it's going to give us a value, but that's not actually the value. That's the semi-annual value. So you have to double that to get the annual yield to maturity, right? So by doing that, if you were to set that as your coupon rate, if yield to maturity and coupon rate are equal, then the present value and the future value are both par, right? So if you want your bond to sell at par and people are telling you it's got to be 5%, then set it at 5%, right? That's really what we're calculating here. If you set it below that, then your current yield is going to be lower, right? Because you're setting this interest rate below the market. And that means your bond is going to sell at a discount because they're going to receive less in that coupon yield. So they're going to have to make up the difference in the capital gain for it to equal that total yield to maturity of 5%. Remember, I said it doesn't matter how much is in dividend or in capital gains, they're going to add up to the yield to maturity. Again, this one's a little bit different where they're showing you prices based on this, like, normally this is kind of how it would look in the paper. They would quote all the different bonds. The bid and ask is just the difference in the price when you're trying to sell it versus the price when you go to buy it. There's a little difference in price there. And that's where market makers make their money. You can almost think of it, if you saw that, it's an older movie now, I guess, called Office Space, and they're stealing like fractions of a penny, but they're just doing it millions of times per day. And that's kind of what they're doing. They're just taking a little bit. You see the difference in the bid and the ask. Will just be a small percentage of that $1,000 par value. But every time they're making these transactions, they're getting that little bit of a difference, right? And that's how they make their money. They don't know what's going to happen with individual stocks or bonds. They're just keeping the market flowing, right? But yeah, so we're going to look at a treasury bond that matures in May of 35. So it's that one in the middle. What would be the yield to maturity if you buy it, right? And so we're saying the par value is 1,000, right? And then I'm going to have to go buy it, right? So when I want to go buy it, I'm going to be paying the higher price. I'm going to be paying that ask price. When I go to sell it, they're only going to give me the bid price, right? So when I buy that, I know that my present value is going to be 1,000 times 104.6461. And the payment, let's see. The rate. So you see the rate is 5.424, right? So you'll multiply that by 1,000, right? And then, well, that's a percentage, right? And then you're going to divide that by 2, right? And so you're going to get the $54.24, and then divide that by 2. We're going from 22 to 35, so that's 13 years, and we're going to double that because, again, this is semi-annual payments. And then once we compute the yield to maturity, we just have to remember that is a 6-month yield, and so what we need to do is double that, and then that will give us the yield to maturity on the annual rate. Okay. This is the Fisher equation. There was like a few of these when I was looking, but they're all the same thing. So Irv Fisher lived like 100 years ago, and he came up with this calculation that if you take what the real return is and add 1 to it, and then multiply that by what your inflation is, plus 1%, then what that product would give you what your nominal interest rate is, plus 1%, right? And the reason we have to use this 1 plus just has to do with the nature of sort of this geometric progression. So I don't want to get too in the weeds in the math, but just understand when we're dealing with interest rates, usually you will add one to whatever the interest rate is, whether it's nominal, whether we're talking about a some sort of premium put on it. We normally add one to it. Um, so in our particular case, we don't know what the real is, but we were given the nominal return. And so the nominal return is at 17%. And we know that the inflation was 3.6%. So if you see down there, it would be 1.17 is equal to 1 plus R times 1.036. So there's a little bit of algebra. So the 1.17 divided by 1.036, take that quotient and then subtract 1, and that will give you your real return. Sometimes they ask you to calculate what inflation must be if this was real and this was the nominal return, or they tell you this is the real and this is the inflation. What is the nominal? Just know that the lowercase r, we're going to always use that for real return, right? So just be prepared, I guess, for that. When you see a capital R, normally that's a rate that's given to you. This is a problem dealing with price ratios, right? And so we have a company and they don't have earnings, so we can't say, price to earnings, and this happens with startups, right? It takes a while for the company to actually start turning a profit. And so what we can do is use some other metric that we think is better. In this particular case, it's sales, right? So as they're growing in sales, we're going to use that as our benchmark to calculate what the stock price should be, right? Because there is no like intrinsic value because we're not earning anything, right? Um, so if the benchmark is for price to sales is 5.7, how much do you pay? If it's 5.1, how much do you pay? And so the first thing you have to do is calculate, well, what's the sales per share, right? And so we're told the sales was 1.7 million. We're told the shares are 145,000. So it ends up being $11.72 per share, right? And then we know that we've got two different benchmarks to multiply it by. So you multiply it by 5.7, get 66.83, multiply it by 5.1, we get 59.79. So even knowing the other things, just depending on where you put that price to sales ratio, would tell you whether or not to buy if the stock were, say, $62, right? So you got to be careful when you're making your assumptions as to what it should be. Here's another one, but this one is using actual earnings, right? So we can use price to earnings ratio. But in this one, they told us the two different PE ratios, 19 and 21, or 19 and 22. And they also told us what the earnings per share was. So you can just multiply that, and that would tell you what the stock price should be based on the PE ratio. Okay. Now I said before about intrinsic value and that type of thing. So this is using that. So the intrinsic value of a stock would be the present value of the current cash flows. The cash flows from the stock would be the dividends, right? So what we have to do is calculate, well, what is today's value of this future string of cash flows? So we know that they just paid $9.75 per share. It's going to increase by $7.75 per share for each year of the next 4 years, and then it never pays another dividend. So we have to get all of our money by the fourth year, right? And so since we have a required return of 16%, then we just take each of those 4 years and then discount that back to the present value, either 1, 2, 3, or 4 years. That's what those powers are in the denominator. Once you add up the value of those 4 dividend payments, then that will tell you what the current share price will be. Here's another way of doing the same type of calculation, only we have this growth model, right? Where the dividend is going to grow.
So for the first 8 years, they are paying no dividends, right? And then they're going to pay $14 per share starting on that 9th year. And then it's going to grow continuously at 5.75%. Okay. And then we have the required return on the stock is 13.75%. So we need to calculate what our current share price is. Okay. So that pricing formula you see, PT is equal to DT times 1 plus G divided by R minus G. So we were told what that first dividend, would be. If you notice, PT and DT, those are the same, right? So it's the same period. If you multiply that DT times 1 plus the growth rate, that will tell you what the dividend will be next year, right? So it's like PT, and then if you remove the 1 plus G, it'd be D of T plus 1. Right. So when you look further down where you see price at time 8 and use the dividend at time 9, then you have, that's why, right? Because what we're going to get is the price at time 8 with the dividend at time 9 because of that additional time of growth, right? When you're putting things in the calculator, that's why you can that the payment doesn't start initially at the same time as the present value. Instead, that payment starts at time 1, not time 0. So I hope that's not confusing, but you just have to use the next period dividend, which you can use this period's dividend and just grow it at that constant rate. But that's why that number is a bit different. And you see capital R minus G. R in this case is that required return of the stock. So this is what we're saying that it has to be, but then we're going to subtract off that growth rate, right? So it's as if we require a lower rate of return, but what's going on is our cash flow is increasing at that higher rate. So once you put that in, you can get the price that it will be at time 8. But then you have to remember that that's at time 8, not at time 0, right? Which is what you're going to currently buy it at. So what you'll do is you'll just take that price at year 8 and discount it back at that same required 13.75% for 8 years. So, or divide it, raise to the 8th power and divide by that number, right? And that will tell you what the current share price would be. So you would pay $62 today. You receive nothing for 8 years. And then starting in year 9, you'll get $14, and that will grow at 5.75% per year. Speaking of the required return, and in this particular case, you notice the previous equation is just rearranged, right? So the required return, it would be equal to the future dividend divided by current price plus G, the growth rate, right? So in this case, we were told that the next dividend would be $2.65. We're told that the current stock price is $48.90. And then we're told that there's this growth rate of 6.5%. So, and I'm sorry, I put that in incorrectly. It should not be 0.07. It should actually be 0.065, kind of rounded. But yeah, that's all that is. I always round it 2 digits, and I'm sorry about that. Here's the same type of required return calculation, but again, this is the larger one showing the different stocks and all their yields and PE ratios, and we are looking at Acevedo company, and so we know that the growth rate for the last 10 years has been 4.25. We continue that 4.25 growth will continue. So we know what the dividend, let's see, the last, the dividend that was paid was 0.55. See, it's next to the name, right? They give the dividend right next to it. But we know that that was the one just paid, right? They don't know what the next one will be, but we are confident that it's going to grow at 4.25%. So you just take the current one, multiply it by 1 plus that growth rate, right? And that'll give you the new dividend. You'll divide that by the current price, and the closing price on this day was $15.80. It's the next to the last column, right, for a CVDO. So you would just use that to calculate the ratio of the next year's dividend to the current price. You then add that same growth rate, and that gives you the required return. So here's another one, do a dividend yield. And they're saying, calculate the highest and lowest dividend yield. Well, the dividend we know what it's going to be, right? We've calculated the dividends before. This is Georgette. So it's the second one down. You see that they just paid $2.14. So I have that. And so what is the highest and lowest dividend yield? Well, remember, dividend yield is the dividend divided by the price, right? That's all that means. And so for that to be the highest number, and if the dividend doesn't change, and it doesn't, right? We got it printed there, it's $2.14. We have to change the price. So for that equation to be the highest, we need the price to be the lowest. And for that equation to be the lowest, we need the price to be the highest because it's in the denominator. And so we're going to just calculate based on that 52-week high price and low price. So next to Georgette, you see the high price was $56.41, and the low price was $34.20. So if you use the low price, you'll get the highest possible dividend yield in the last year. And if you use the highest price, you'll get the lowest possible dividend yield for the last year. Okay, this one's looking at price and yield calculations. And so we're looking at Kinney, which is the one in the middle there, right? Kinney Corporation. And we are told there's a coupon of 7.22%. It matures in 38 and is currently 22, right? So we have 16 years between them. The bonds have a par value of 2,000 and they're semi-annual payments. So again, semi-annual means we're going to have to change our payment, change our interest rate, and change the number of periods. But we can put our future value in, we can compute the payment 7.22% times 2,000, right? But then we'll divide that by 2. The interest rate, the last yield, if you see that column, it's the next to the last one, right? That's yield to maturity, right? So, but remember that's annual, so we'll have to divide it by 2 for semi-annual. And then the number of periods, it's 16 years, which is 32 half years. But then when we do that, we can compute the price, right? And then once we have the price, you can take the current yield, or to calculate the current yield, that's what they're asking for. You take what your current payment is, right, and divide it by the current price, right? So the coupon payment divided by the market price of the bond is the current yield. And again, if you notice, this is selling at a premium, right? Because it's more than $2,000, and our current yield, right, is higher than their yield to maturity. And the reason that's being is because we're going to have a negative capital gain or capital loss, because our value is going to fall from $2,200 to just $2,000, right? And that's why the current yield is so high. Okay, here's one just calculating the price of a bond. They give us a coupon rate. It's paid semi-annually. It's 15 years to maturity. The yield to maturity on the bond is 3.8%. That's an annual one. The par value is $10,000. So how much would it sell for? And again, it's semi-annual, so you'll have to calculate all of those annuals and divide it by 2 for the payment and interest rate, and multiply it by 2 for the number of periods. But then we'll just compute the present value for that one. So, all right, that covers everything for Module 4. If you have any questions or anything, please email me or a facilitator, and we will get you straightened out. Thank you so much.